Okay, Bismillah ar-Rahman ar-Rahim. This is our friend function. How is a friend function working? So the first thing is, for example, we have in a class a data which is in a private section. So this is a private. So we know the private section data can be accessed only by some member function in a public, and outside, we can access this. In fact, we have to create the object of this class, then that will access the member function, and the member function accesses the private data. But sometimes we want to have a outside class some function. So for example, I'm having print a, right? It's an outside class function. I want to print this a, which is the private data of the base class. I want to access that using the outside function. But how is it possible? Because outside function cannot access it. So we have what is called the friend function. We have to make this print a as a friend to the class. If it's a friend to the class, it can access its private. So what I'm doing is I am doing what? I am creating the object of the base class, and I'm saying ob.show. That's no problem because show is the member function of the class ob. Okay. Similarly, I'm now calling the print a and sending it this ob. Okay. So this is my print a, and this ob is copied in the g, and I say g.a is equal to 56. That's why I'm accessing a as if using the object, because now g or ob, they are same. Okay, so using the object, I'm accessing the a, g.a, as if the a was in public, but this was not in a public, so you cannot access it like this. And in a function like this, which is outside the class, you can't access it. So if I run it, it will be error. But what we do is we have to make this what's called as this print a as a friend of the class. So what I do is I will say make him a friend, this print a, and you're passing the base to it and make it a friend. So when you click it, it's no problem, it will run. The first is 23, then 56, because there was a 23. When I say show, I call it the show. It is 23, and when I say then print a, it initializes a with the 56, and I'm printing the a, no problem whatsoever. Okay. Now this is another thing, that is to say how we bridge the two classes and by a friend function. What I'm doing is I'm very simply making class 1, and I will tell you what is this. This is class 1, and int a, it has a private int a, and in a public we have a constructor which initializes a, and a class 2 has a b and a constructor which initializes b, and we have a print function, we have an add function. We pass objects to it. That's a one object and two object, right? That is here. I am creating object ob of 1 and ob2 of 2, and I am calling the add, sending it the two objects. Now if I want to, I am using the add. This is not a member function, this is outside the all classes, but it can access the private members of all the two classes here. So how can we do? We have to make it the friend. So we say friend wire add, and it has 1 and 2 as arguments. The prototypes, we have to declare it, and I have to declare prototypes here, but with the friend as a function, right? With saying the friend there, right? So but only one problem is, because if you, or for example, you're calling the add ob1, or you're actually creating the class 1 of ob, the problem starts here. You say 1 ob, and the ob class is being created, right? I mean ob object is created of type class 1, so therein it's meant that it's saying wire add 1 and 2. 1 it knows, but 2 it doesn't know. So what we have to do is we have to declare the class, because it doesn't know what is this 2, so we have to tell him in advance that 2 is a class. So this is called forward declaration of a class. So before we can run it, we have to do the class 2, only to tell compiler, because we know at the time of creation of the class 1 object, we will encounter this 2, and it will not be understood what this 2 is. So what you do is you will just do what? You will do a forward declaration. So now when I call the add function, it adds a 1 2 3 and the b of class 2, right? And it gives us the answer, that is the 468. You getting me? So this is how the front function acts as a bridge between the two. I'm doing a little twist here. I'm doing what? I'm creating here in the class A function called show, which shows the A, and in this add I'm doing updation to the O.A, right? Is a 12. So what happens here is this add function does something to the O.A, right? So O basically is nothing but the object OB. So we are tinkering with the object OB. And when I'm saying OB.show, it doesn't update this because it is passed by a reference, not passed by value. So what happens is, because it's 123 again, it's not changing to the whatever the value I have put in 12, because whatever you are doing, you are passing OB, but it's passed by reference only, passed by value only, not by reference. So if you're changing here, that doesn't matter. You getting me? Okay, but we can pass by the reference, so that can update also. Now if you want to change the value of the A, then you have to pass by reference. And in C++ we have a reference variables. If you excuse me, and let me explain here reference variable. Quote plus C++ time second. And okay, I have got, for example, int a equals to 23. Now if I say, for example, int ampersand b is equal to a, what happens here is the b is the second name for the a. This is different from the pointers, the ampersand in a C, which says address of b. In this case, it's not the address of b. It's to create the alias, the second name of a, right? So that's what I'm doing. I'm creating the second name. It's not like the address of b is equal to a. That would be logically incorrect, right? What it is here is, it is the b is a second name of a. So if I say, for example, I say b equals to 34, right? And I see out a, and if you could see, a will no more be like 23. A was 23, but I have put the 34 in a b, right? But I'm putting a again 34, because the b or a is one of the same things. It's two names for a same memory location. So we can create a reference variable. It's called reference variable in C++, which acts as the same as a. Similarly here, if I want to, for example, pass it by the reference, I don't need pointer and assignment operators as in we do C, pass by reference. Here what I do is, because in a C we have to do first pass the address and then get it in a pointer and all that. We can do that here also, but we have a very shortcut stuff here because we have the references here. So I can send the OB, simply OB, and I will create its reference here. I will create here its reference here. So ampersand O. This ampersand O doesn't mean an address. This means a reference O. That means this is second name for the original object OB. So it will not be by copy. It will be exactly, the O will be exactly the second name of OB. So what you do here is exactly, you will work on the OB. Now then, if what you do is you have to create the prototypes also of the same type, you have to say ampersand here, and you have to say ampersand here in the prototypes, and you give it a go. Now you could see the A will be changed. That is 12. The A is no more than 123. It has been changed to 12, because what you do now here in the class 1, in fact, what you do with the A, which was 123, where here, well, I'm changing the A, O.A I'm changing, but exactly changing the object 1 dot object 1 dot A, that's of class 1. You getting me? Okay, so it's about this, right? So that's all for today, and we'll continue with this class. In the meantime, take care and masalam.